Grade 10s. How are you guys? It's me again, Marshall AC Candiado. Welcome to our fourth lesson in this series of video lessons. Right, so as promised, we are having a continuation on the topic halogens, group 7 elements. In the last lesson, we looked at the same group 7. We looked at its properties. We looked at the reactivity of these group 7 elements, how their reactivity decreases as you go down the group. We looked at the concept of electronegativity, and then today we want to just finish up on that same group. Didn't want us to rush through this concept, because what is important is us grasping the concept and understanding what we are trying to do. So our objectives, again, I will highlight some physical and chemical properties, right? And then in this lesson, we'll want to write some chemical equations for the ionic bonding of group 7 elements, right? So we'll write bonding equations for ionic equations for group 1 and 7, group 2 and 7, just so we are familiarized with what those structures look like. Then by the end of this lesson as well, we should be able to explain what displacement reactions are. We should be able to explain what displacement reactions are. And if we are given a set of conditions and we are asked whether a displacement reaction is going to take place, we should be able to say yes, a displacement reaction will take place because of A, B, C, D, or no, it won't because of this. Okay, so you may take this time to just mull over the objectives of this lesson and just prepare yourself so that we have a good lesson. Yeah. Okay, welcome back, guys. I hope you were able to look at those objectives of ours. And then the first thing straight into this lesson, we're going to look at the concept of melting point and boiling point. I touched on this part in the previous lesson, how melting point and boiling point effectively increase as you go down the group. But why is this? We mentioned something about how the number of electrons increases as you go down the group. So if you're holding your periodic table, you will find that the atomic number of chlorine is less than the atomic number of bromine. It's less than the atomic number of iodine. The atomic number is increasing as you are going down the group. Let me just put the atomic numbers there for you. Right. So if we look at the atomic numbers, the atomic number for chlorine, for bromine, for iodine, for acetone, we will observe that chlorine is chlorine 17, right? Chlorine, this is the atomic number, not the mass number. The atomic number referring to the number of protons that are in the atom, and the number of protons is equivalent to the number of protons is equivalent to the number of what? To the number of electrons. So chlorine has 17, bromine has 35, iodine has 53, acetone has 85. Now, with this increase in atomic number, it means that the electrons are now more and they're increasing as you go down the group. Now, understand this. All of these electrons that are found in these atoms are able to form what we call temporary dipoles, and it's as if it's more difficult for you to pull them apart, right? These electron pairs, we have several electron pairs. The more electrons you have, the more electron pairs you are going to have. And these electron pairs, for you to break them apart, you would need a lot of energy. You would need a lot of energy to break them apart, which is why the boiling point is increasing as you're going down the group, because the amount of energy that you're going to need to break apart those bond pairs that they're there as a result of the increased atomic number, right? Increased presence of electrons. The amount of energy that you require to break apart all of those bond pairs is massive, right? So the boiling point increases as you go down the group, right? Same as with what? With the melting point. For acetone to melt, again, you have to heat it to a very high temperature and then it melts. And then you have to heat it to an even higher temperature before it boils. right? If you were to look at fluorine, fluorine is already existing as a gas at RTP, which means that it does not really need as high a temperature as compared to those of chlorine, bromine, and iodine. Right, so if we also look at the colors of this one, chlorine gas, what is its color? Chlorine is pale yellow. Pale yellow, these are just physical properties. Bromine, pale green. Pale green. Iodine, black. I'm sure we've seen iodine crystals in the lab. Iodine crystals, which we usually use in that experiment where we want to show sublimation, where we just hit the iodine crystals and they change directly from solid to gas, right? As an example of sublimation. I hope you guys are aware of this, right? So, MP and BP, melting point and boiling point, increase as you go down the group. Increase as you go down the group. And if you were told that you have a group 7 element and it is green in color, which element is this one? And then you say, which one was pale green, by the way? Then you remember green, bromine, bromine, green, right? Black, iodine, chlorine, pale yellow. Okay, so you just allow yourself to remember, right? These are basic concepts. These are basic concepts which allow you to understand and to know more about the group 7 elements. What we want to do now is we want to look at the ionic bonds that are formed, right? In the last lesson, I did one just as an example where I drew one for potassium and fluorine, and then I asked you guys to draw one for magnesium chloride. Okay, so I'm now going to draw the one again I'm just going to write the ionic equation. I'm not going to draw the Bohr diagrams. So we'll write the ionic equations let's do one for magnesium plus chlorine. Okay, let's do another one for potassium plus bromine. Let's do one for lithium plus fluorine. Okay, let's do those three. Let's do magnesium and chlorine, potassium and fluorine. Let's do lithium and fluorine. I don't know what I'm saying, right? But I'm going to draw. I'm going to write 3 equations there, right? So let's have the first one. The first one, let it be magnesium and chlorine, right? The ionic equation for magnesium and chlorine to give us magnesium chloride. The second one, right? The second one, let it be sodium plus bromine to give us sodium bromide. The third one, let it be lithium plus fluorine. Fluorine to give us lithium fluoride. Those are the equations that I want to see that you guys will write. I'm going to write them as well on the board, and then you guys will just confirm with what I would have written. Okay, cool. Let's do that. Just maybe 3-4 minutes. Okay, welcome back, guys. So I hope you were able to write your equations, ionic equations for magnesium plus chlorine, sodium plus bromine, lithium plus fluorine, right? So why did I ask us to write these equations? It's because I wanted to see if we could get to a point where we understand the part of the balancing and how we get these products to say magnesium chloride, how to say magnesium chloride. Because I know that in the beginning, whenever someone would just say magnesium chloride, you say, okay, magnesium is Mg, then chlorine is this one, so that is fine. That is magnesium chloride. But you realize that no, this is not magnesium chloride. Magnesium chloride looks like this, MgCl2. So I even put now the way which we allow ourselves to get to these products. To say, remember, magnesium is in which group? Magnesium is in group 2. Magnesium is in group 2, which means that it forms a cation with the charge of +2, because when it reacts, it gives away the 2 electrons in the outermost shell. It gives away the 2 electrons in the outermost shell, and it forms Mg2+. Chlorine is in group 7. Remember, we're talking about group 7 electrons. So chlorine is going to then gain 1 electron, and it's going to form the chloride Cl-. Then you recall that we said when we want to write now the formula of the product, what we do is we do what you guys kept on referring to as a cross multiplication, where you have the 2 from the magnesium going down and finding its position here at the suffix or at the base of the chlorine molecule. Then the negative comes here, and because it's 1, it has no effect on our final written formula. So the 2 comes down there, then you have it here. This is the 2 plus. It's now here, and it's now MgCl2. That is how you get the product magnesium chloride. For your equation, it just then becomes Mg plus Cl2 to produce MgCl2. Why do you write Cl2? Because we said in the previous lesson, group 7 elements are diatomic. They are always diatomic. So they produce this one. Now let's look at sodium plus bromine. Okay, so before we balance the equation, right, I've already balanced these ones. Right, so before we balance them, this is how you would have written the equation. Lithium plus fluorine, sodium plus bromine. And you would produce, this is the product that you would form. Sodium bromide, lithium fluoride. But observe that here on the left side of the equation, we have 2 bromine atoms, right? We have 2 bromine atoms, whilst this side of the equation, on the right side of the equation, we have 1 bromine atom, which means we need to balance this equation in terms of bromine. So if on this is the left side, this is the right side, right? So on the left side, we have 2 BRs, and then this one, we have 1 BR. What we can do is we then multiply, we say times 2, so that we can balance this one. And because we have said times 2, we gotta put the 2 here, we put it at the back, because our product will always be NaBr. It won't be NaBr2 or Br3 or Br4, it has to be NaBr. So the place where we can put this 2, so that we can balance that these 2 bromines can balance the 2 bromines here, is this side. But observe, we now have 2 sodiums, whereas this side we have 1 sodium. So we have to balance the equation again for what? For sodium, because now we have 2 Na at this side, and this side we only have 1 sodium. This side we have 2 sodiums, this side we have 1 sodium. So again we have to multiply the sodium on the left side by 2. And we come this side and we place the 2 here. So we now have 2 sodium plus bromine to produce 2 molecules of sodium bromide. And we do the same for fluorine. We do the same for lithium plus fluorine. Because there are 2 fluorines, we multiply by 2 here. The fluorines are now balanced, but the lithium is not. So again, we multiply by 2. That's how we write the ionic equations for group 7 elements. Right. So now I would also want us to look at the concept of displacement. Okay, so just take a few seconds, just take a minute or so to just look at how we balance those equations. Rita, I hope you guys, and Prince, I hope you've also observed how we have balanced this equation, and Greg also. I hope I've mentioned everyone's name, because I think about all of you guys all the time, right? So I hope you have now understood how we balance these equations, right? So just take a few minutes just to observe. Okay. After this, we'll look at displacement reactions. Okay, so let's now look at the concept of displacement reactions. Now, what is a displacement reaction? A displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its compound, right? A more reactive element displaces a less reactive element from its compound. I'm sure you have observed and you guys have seen displacement reactions all the time. They take place all the time at the school. You have a couple, right? You have a couple, let's say so-and-so is dating so-and-so. I won't mention names, but then a more attractive individual comes in, and then you find that so-and-so leaves the other person and then decides to date the other person because that one at the time appeared to be more reactive. True. I've seen it happen. I've seen it happen at our school. I've seen it happen at several other places, and it happens in life in general. You have two people who you think these guys are together, and then someone just comes in and they say, whoa, I'm going to take your girl from you, or I'm going to take your guy from you, and they just take them away. And you're like, what's going on? They are more reactive, or you would be more reactive than the previous individual. Okay, it's just a simple example. So this is a reaction in which a more reactive element displaces a less reactive element, and we're talking in relation to group 7 elements, right? So we have a situation where in the first scenario, right? So in the first scenario we have potassium bromide being reacted with a solution. Potassium bromide is being reacted with chlorine in solution. Right? So there is already the compound potassium bromide. Potassium is already bonded to bromine, and they have formed their lovely little compound, and it's known as potassium bromide, and they are happy together. Right? Then they are placed in solution, and chlorine is introduced. Now remember, in group 1, in group 7, chlorine is higher up in group 7 than bromine is, which means that chlorine is way more reactive than bromine, right? We won't even talk about fluorine because that guy is the most reactive of them all, right? So chlorine is more reactive than bromine. And the moment that it is introduced into this equation, right, chlorine will immediately displace the bromine, and you will find that at the end of the reaction, the potassium has now been taken by chlorine, and you now have the product potassium chloride. And bromine, where does the bromine go? You just have the bromine lying around in solution. It's still there, it's just walking around. It's just now walking around, and it's not bonded to the potassium anymore. Why? Because chlorine is more reactive than bromine, and therefore it will displace bromine. If this was potassium iodide, chlorine again would displace it, because chlorine is more reactive than the elements that are below it. So that is the product that you form. Okay, so you say, what about in a different reaction? And then we say, we have, at the beginning of the reaction, we have sodium chloride. The compound sodium chloride, table salt, yeah. Sodium chloride, and then you put it in solution, and then you introduce bromine, right? Bromine has now came into this situation, and it wants to take the sodium from chlorine. Is it going to be possible? Is it going to be possible for bromine to take the sodium away from the chlorine? What do you guys think? From that equation, we can see that no, it's not possible, because the product remains sodium chloride, and bromine still walks alone. You will never walk alone, but bromine does. Bromine is walking alone there. Why? Because bromine is not as reactive as chlorine, right? Because chlorine is higher up in the group 7 table, right? On those elements in group 7. If we were to have this similar reaction, and we were to say 2 sodium chloride, right, plus, now let's introduce the big boss, and we introduce fluorine himself, F2. If we were to introduce fluorine, right, remember fluorine is the most reactive. What do you think the product will be, right? What do you think the product will be? You can just pause for a couple of minutes, just for 1 minute, and write the product for that reaction and tell us what's going to happen. Okay, did you guys manage to get the answer? Definitely, that is the answer. If you have fluorine now being introduced to react with sodium chloride, because fluorine is the most reactive element in group 7, it is going to displace chlorine. It's going to remove it. Okay, now we're going to be left with sodium fluoride. Now chlorine is the one who has to walk alone. So it's just a matter of reactivity. Right, in life and in group 7, some of the elements are more reactive than the others. The ones at the top, fluorine, chlorine, they are more reactive than the elements that are below them, right? The same thing, if bromine was to go into a reaction and it gets there, and let's say there is lithium iodide, right? But because iodine is lower than bromine, bromine would simply displace the iodine. Okay, it will simply displace the iodine. It's just a matter of saying the element that is at the top is the most reactive and therefore will displace any other halogen that is attached to any ionic metal bond that is there. Okay, the ionic bond that is there, not ionic metal bond. Metal bonds are something altogether, right? Something different altogether. So bromine is displaced by the chlorine. It cannot displace chlorine. That is what a displacement reaction is. So make sure you get the definition of what a displacement reaction is. You guys, I'll also task you with just a small exercise where you look at the uses of bromine, the uses of chlorine in industry, in pharmaceuticals. You just look for those uses and then we'll discuss some of them. But basically we have reached the end of this lesson. We have looked at some of the remaining physical and chemical properties and tried to explain them in a bit more depth. We have written equations, ionic equations for the ionic bonding of group 7 elements with group 1 and with group 2 atoms as well. We have clearly explained what a displacement reaction is. You have now the knowledge of what a displacement reaction is. So in the next lesson, we'll move to group 8. Okay, so this is group 7. We'll move to group 8 in the next lesson, next couple of lessons, or maybe one lesson. We'll look at group 8 and then we'll look at transition elements. But for now, guys, again, you have been wonderful as always. Thank you very much. This is your teacher, Marshall A.C. Candiado.